Hello guys, this is how to implement the queue abstract data structure using linked list. This is my Python program. First, I created the class node to get the value inside the node. Then, I created the class queue to implement these nodes into the queue. For empty node, return self.front is none. Next, to enqueue the node values to the queue. This is the algorithm or the function in enqueuing the node values to the queue. Next, dequeuing. Dequeuing node values from the queue. Next, line 36. Dequeue function to find and remove the item with the lowest value from the queue, particularly on its front node. So in this function, we need to dequeue from the queue that has the lowest minimum value among the three queues. In order to do that, we need to define the minimum value, so that the minimum value is the value of the front 1, front 2, and front 3. Then we have to compare these three. Next, the queue from Qn if it contains the minimum value among all queues. As you can see, if front 1 and its value is equal to the minimum value, then we need to dequeue from the front 1 or the Q1. Or else, if the front 2 and its value is equivalent to the minimum value, then we need to dequeue from this queue number 2. The same goes with the front 3 and its value. If it is equivalent to the minimum value among the three queues, then we need to dequeue from the queue number 3. In line 54, this is the print function for queues n. Print q1. As you can see, q1, q2, and q3. This is what the user will see when running the program. Function for creating the total value of a queue. This is the total value, which is the summation of all values in a queue. This will determine and help us to find where queue we need to dequeue. If a certain queue has the minimum total value, then we need to dequeue from this certain queue. As you can see, also we have the while loop for the buttons 0, 1, and 2. If the user chose 0, then exit. If the user chose 1, then input the value of workload. Then this is the algorithm for finding and comparing the three summations of queues. In line 123, this means that if the total values in queue number 1 is less than the total values of in queue number 2, also if the total values of nodes in Q1 is less than or equal to the total values of nodes in queue number 3, then the current queue is in Q1. This is where we enqueue another value in Q1. The same approach to the total 2 and for the Q2 and the total 3 in Q3. For the dequeuing, we need to dequeue from the lowest value among the three queues. Then a print function for error message and a thank you message. Okay, let's try to run our program. As you can see, we have here Q1, Q2, Q3 empty because we haven't entered or enqueued values. Then we have 0 for exit, 1 for enqueue workload, and 2 for the queue workload. So we need to enter, let's say 1. Input value of workload, that's input 3. We have here 3 for Q1 and still empty for the queues 2 and 3. Let's enqueue again. Input value of workload 5. We have here 3, 5 and empty. Enqueue again. Input value of workload, let's say 2. 3, 5, 2. Let's try to enqueue again. Input value of workload 1, let's say 1. As you can see, the number 1 is enqueue and being enqueued in queue number 3 because this has the lowest minimum value compared to the 2. 2 is lower than 5 and 2 is lower than 3. So we need to enqueue 1 in queue number 3. Let's try to enqueue again. Let's say, oops, error. I have to repeat. 1, 3, 1, 5, 1, 2, 1, 1. Okay, so there has been some error. Then now we enqueue again. Let's say 4. We have here 3, 5, 2 and 4, 1. Let's try to enqueue again. Let's choose 2. Enqueue again. Oh, okay. Let's try to dequeue. In dequeuing, press 2. So the number 2 here from the previous queue, the number 2 here, at the front, this number 2 at the front is removed after we dequeue. Let's dequeue again. Here and empty. Let's try 0. The program will now exit. Let's try another example. Enqueue. We input workload value 10. We have here 10 empty empty. Enqueue again. Let's say 2. We have here 10 2 empty. Let's enqueue again. Let's say 20. We have here 10 2 20. Let's try to enqueue again. The workload value is 5. As you can see, the workload value 5 is enqueue in queue number 2 because it has the lowest or the minimum value among the 3 queues. 2 is lower than 10 and 2 is lower than 20. So 5 is in queue number 2. Let's try to dequeue. After dequeuing, as you can see, the number 2 at the front is removed. In dequeuing, we need to consider again, or the program considered again, which queues among the three has the lowest minimum value. In this case, Q2 is a total of 7, Q1 is 10, Q3 is 20. So Q2 is the lowest, has the lowest total value. So the program dequeue in queue number 2. So as you can see, the 2 at the front is removed, and we have here 10, 5, 20. Let's try to dequeue again. Oh, now becomes empty. Again, 5 is the lowest minimum value. So Q2 become now empty. Let's try to exit, and the program exited. Okay, this is now the end of my topic about the queue on data structure, and we learned how to enqueue and dequeue considering the minimum value. Thank you.